take an advanced thermal cracking process to take the waste from a solid state into a gaseous state. That gas is then cleaned, filtered and put into either an engine or a steam turbine. The gas that we produce is a very energy rich and very clean gas. The gas has actually received an accreditation from the Environment Agency as an end of waste product, so it's not classified as a waste any longer.
I've been a lifetime in the waste sector, and ultimately I became chief executive of Waste Management International. The concept of advanced thermal conversion technologies was something that I really disdained. I felt that why spend all the money of pre-processing waste before doing anything with it, until I came up to this site. And when I got to this plant and saw it for the first time, I was really taken aback. Taken aback by its simplicity and the magic of a facility and a process no larger than the size of a couple homes, where solid waste come in on one end of a black box and out the other are two outputs. A very clean, energy-rich gas and an energy-rich char, similar to a charcoal. A very small percentage, but the bulk is gas. We put the waste material into a cylinder which is indirectly heated externally in the absence of oxygen. It's like putting something in the oven with no oxygen. And at a certain heat, all those solids vaporize into a gas. It's not a combustion because there's no oxygen. That gas is then heated twice using the gas that we produce, and that gas is then further refined to the point where it's very clean and very high in energy, because all the hydrocarbons in the gas is broken down and becomes part of the gas.
Because of the cleanliness of the gas, we can put that gas into a reciprocating engine, and that reciprocating engine can then be used to produce electricity. The equipment is designed to really be a bolt-on to the end of a materials recycling facility, taking the non-recyclable waste that would otherwise be taken off to landfill or incineration. As such, because the equipment is essentially just an add-on to an existing process, no additional planning is required. Generally, incinerators will be in the order of between 350,000 and 500,000 tonnes of waste being treated per annum. We're looking at a plant that's a tenth the size of that. This means that it can actually be appropriate for a town the size of about 100,000 people, and the waste can be dealt with in far closer proximity to where the waste has arisen.
Our process is not only environmentally friendly, it's also extremely financially attractive. The capital cost for a plant like this per ton of waste processed and per megawatt of energy produced is a fraction of the cost relative to other energy from waste processes.
So the next step is we're building our commercially operational plant, which will be the SG100. We're installing that at the site here in Huntingdon. Once we've tested the new plant, we expect to be able to roll 20 of the plants out in the UK, which will account for about 750,000 tonnes of material that would otherwise be going to incineration or landfill. We've looked at the market for the technology around the world, and there is an enormous market. The waste markets are very different depending upon which country you go to, but the basic principle of taking material that would be non-recyclable has got world application.